Last set of notes we are taking. We are solving systems using matrices. We are solving systems using matrices. First thing that you're going to do when you have a system, so we have this system here, is you are going to turn it into what's called an augmented matrix. Here's what that means. This first equation gets written as the first line in our matrix. The 2 is the coefficient on x, the -3 is the coefficient on y, 0 is the coefficient on z, and then that 4 is the answer. And then you will notice the next line becomes the next line in our matrix. Again, the coefficient on x, then y, then z, then our answer. And then our third line will become the third line in the matrix. Okay, so what you're going to be doing is you will have a system, you will write it as a matrix, and then we're going to be using the calculator. On the calculator, it's something called reduced row echelon form. Reduced row echelon form. Okay. The easiest way to see this is just to do an example. So we're going to do a few examples. We are going to start by writing the matrices, then we will go to the calculator. So let's look at example number 1. It says solve the system using RREF. First thing that you're going to do is you are going to write your matrix. Here's how this is going to work. We notice that we have 3 variables. We have x, y, z, and then we have our answer. Looking at the first line, we have 2x, -3y, 0z equals 4. So write this down with me, please. Next line, we have 1x, 2y, -3z equals 0. Last line, we have 4x, -1y, 2z equals 3. So that is our matrix. What are the dimensions of this matrix? 3 by 4. Okay, so we have a 3 by 4 matrix. At this point, you're going to go to the calculator, and what you are going to do on the calculator is you are going to do RREF of that matrix. And that's how we're going to come up with a solution. At this point, I'm going to swap my screen to the calculator. So pull your calculator up, please. Okay, so that is not our answer, but that tells us what the answer is. The first thing that I want you to notice is in this new matrix we have, the first 3 numbers, this matrix is called the identity matrix. What you should notice is it has 1s on the diagonal, 0s everywhere else. 1s on the diagonal, 0 everywhere else. Now, if we remember, we said x is the first number, y is the second number, z is the third number. So if we follow those 1s, we have 1x, 1y, 1z equals these last numbers then. This is our solution. That is our solution. So if I asked you what your answer is, you're going to write your answer as what's called an ordered triple. It's kind of like an ordered pair, except there's 3 of them. So it would be 31 over 44, negative 19 over 22, and negative 15 over 44. That is our answer. So while it took me a bit to explain it, it should be a pretty quick process. I am always going to ask to see the setup, what you get from the calculator, and then your answer. We're going to do the next one together, and then you're going to try a few. First of all, there's a typo on B. This should be a 2W. So can you add a W there, please? 2W. Okay, so when we are setting up our matrix, in this case, we have W, X, Y, Z, and the answer. So, first equation is 2W, 2X, 0Y, 1Z equals 6. And then, next one, 2W, 5X, 1Y, 2Z equals 10. 2W, 4X, 1Y, 1Z equals 8. And lastly, 3W, 6X, 0Y, 4Z, 16. What I want you to do right now, put this in the calculator, please, underneath the matrix. I'm going to work on switching over to the calculator again. You right now should be entering that in a matrix in your calculator. Okay, I don't have enough room on my screen to write that new matrix. Hopefully you do. Ultimately, our answer is 0, 4, -6, -2. Are we confident we can try the last two? There are 3 things I expect to see. The first matrix, the matrix from the calculator, and your answer. I'm going to tell you the answers for the next 2 are funky. So I want you to write your matrix, do your RREF, write the answer, and then we will go over. You have 5 minutes to do those 2. So try those 2 on your own right now, please. Here's what I got. Do you all agree with the resulting matrices that I have on the right? What do you notice about these resulting matrices? How are these different than the 2 that we did previously? They don't have the ones. They don't have what we call the identity matrix. This part right here is different. Did you see that? Okay, here's how to read this. Again, this is X, this is Y. This is our answer. Anytime you don't see that identity matrix, what is most important is this last row. Here's what that last row says. 0x plus 0y equals 1. Does that make sense? 0x plus 0y equals 1. No. 0x plus 0y, that's 0. 0 equals 1? That doesn't make sense. So what do you think that means about our system? No solution. No solution. If we follow the same idea for B, again, it's x, y equals. So this time we get 0x plus 0y equals 0. 0 equals 0. What does that mean about our system? Close, not all solutions, but infinitely many solutions. So always pay attention if you don't get the identity, if you don't get the ones and the zeros, it's either no solution or infinitely many, and you decide by looking at the last row.